warahmatullahi wabarakatuh. I bid to Prof. Khairul and also Dr. Idris. So for today, we are from Group 11 of EMM 3526 Computer Aided Manufacturing Project. We'll do our presentations of case study, which is Plummer Block. My name is NURUL binti ZULARIFFIN and my metric number 197659. My other teammate is NAJIHAH binti RAZAK 198897. NURUL FARHANAH binti Muhammad FIRDAUS 196034 and also ALEIF HAKIMI bin ISMAIL 197551. Next. Okay, so for the introduction, computer-aided design software is a design and technical documentation technology that replace an automated method with manual drafting. So this CAD software, it helps people to draft construction document, explore and visualize design plans and concepts. Lastly, it to simulate how the design perform in the real world. So 3D modeling technique, which is drawing or design, is used to draw parts in CAD software. So for this project, we are using the CATIA V5. Next, simulations of 3D design may be done by planning a machine procedure in complete sequence from the 3D drawing, which by the CNC code, which is GNM code, is provided to run the machine in CATIA V5. Next. Okay, so there are two types of machine, which is the milling machine and also the lathe machine. So the post-processor of the milling machine is Okuma, whereby this machine, it is where the machine cutter rotate in the angle with the two axes to extract the material from the workpiece. For the lathe machine, the post-processor is Mozak, whereby the workpiece rotate around a stationary cutting tools to extract the material from the workpiece. Next. Okay, so for this project, we choose a plummer block, which consists of a few parts, such as the base, bearing brass, nut, bolt, and also the cap. So this part will going through the 3D drawing, design, and machining process, which is the milling and also lathe machining. Next, I will pass this to my other teammate.
Okay, so I will start to explain one of the part of the plumber block, which is cap. So as you can see in the slide, this is the best the drafting or the drawing of the cap itself. As the first drafting is the front view, which is the second picture is the right one is the front view, but more focused on the middle, which is the hole at the middle. And then the other is the top view and also the isometric view, which is the how the cap is look like itself. As you can see, the dimension is being stated in the picture. So next, I will proceed on how I design this part. So, okay, the first step is I start to draw the circle as you can see the picture. Hope you can see it. Okay, so there will be two circles, which is the radius of 58 and also 32. And then I draw the line as stated as a parameter as stated in the previous drafting. And then I erase, for step 2, I erase all the unnecessary part to make the shape look like that. And then I mirror about x-axis to get the step 3. And after that, I exit the sketch and then pad about the line of 32. Now you get the as shown as in the picture. Okay, next is a step 5. I have to do a pocket. So basically, I have to do a pocket. So I draw a circle at the center of the part itself, and then I draw a rectangle to make sure it can cut through the pad of the design before that. So as you can see, the pocket is applied at step 6, with the depth is 32. And then the step 7, you can see how it cut. And after that, I proceed with the draw a circle at the side surface itself, but I just make one circle at the one side and then I mirror it about x-axis. So the circle is with a diameter of 19 for both sides. So after that, as you can see, I do a pocket for both circle up to last. So it through the surface of the part, as you can see in the picture of step 8. And then after that, I do a circle again at the front. As you can see, this is a front view of the part. The circle is 34 in radius, a little bit bigger from the circle that I draw at the first step before. And then this is the circle is the purpose to do a pocket at the center of the cap itself. I do a pocket 32 as the thick pad we made earlier is 32, so it have to be same. Okay, and after that, step 11, this is for the hole at the middle. The hole at the middle is a diameter of 3. And then, as you can see, how I drew that, which is I use the positioning sketch, and then I coincident it with the center of the axis, X and Y. And after that, I insert the diameter of 3 itself. And this is not a normal hole, it's a tapered hole, which is a degree of 15. So as you can see from the right picture is the final product of this part. Okay. So the next one is the machining for cap. Okay, the machining for cap. Okay, as you can see, the first picture is the manufacturing program and part operation. And based on that, I already choose the part body and also the rough stock of the part design itself. And then I start with the swapping part for the first step. Okay, actually swapping part I do twice with a different tool. So swapping part, the first swapping part I do with tool and mill T4. It's diameter 8 mm and radius corner 2. And second part I do swapping also but different tools diameter, which is 3 diameter and radius corner is 1.5, a little bit smaller to make sure it's smooth. And I apply the swapping at the upper part of the part itself. So next one is step 2 and 3, which is roughing. Roughing I do twice also for the upper part and the below part. So for roughing, I choose tool end mill with radius of 10 mm RC0 to make sure that the part is being rough as the exact shape. And the next is drilling. Drilling is for the hole. Hole, I have 2 holes with a diameter of 19 up to last. So I use tool end mill with diameter 19 RC0. Okay, and last but not least is for small drilling at the center of the part. So here I use the same thing. And don't forget to change the tool axis to make sure that the tool is at the right position when you want to apply any process program on your part. Okay, as you can see, the last one is the final look of my machining process. Okay, this is the video simulation. It's a little bit longer, so I will skip part by part. Okay. Okay, this is the first swapping. You can see the tool is a little bit bigger. Okay, it swept through the upper part. And then, okay, this is another second swapping. As you can see, the tool is a little bit smaller. And this is the roughing the first part, which is at the upper part of the surface. Okay. Okay, this is still the upper part. I will make it now. Okay, it start to roughing at the lower part as I change the tool axis with the same diameter, with the same tool end mill tool that I use. So next, roughing. Oh, it's habis. Oh, it cannot repeat again, it will be so long. Okay. Okay, it's roughing, I'm so sorry. Okay, and then it drill. Okay, the 2 drilling part is at the end of the video lah. So I think that's all for my part. I think I take up too much time, so I will proceed to the next part, which is the base. Farhanah will continue with this part. Thank you very much.
Thank you, Najihah. So I will explain about the base for this plumber block. So this drawing is basically the drafting of the isometric base. So we can see that the isometric view of the base of plumber block, and then we have top view, front view, and left view. So next. So this is the design for the base. So the first step is to build the base of the base. So the first one I will the first one I draw sketch a rectangle for the right side, and then I mirror it to the left side using the vertical axis. So then after that I pad it to 32 millimeter. So next, then I choose the upper surface of the base, and then I build uh this block. So then I pad to 66 millimeter, so I get the right side picture. So next, so this is the third step and fourth step of the sketching of base. So the third step is basically I pocket the figure above, top left figure. So I pocket it to up to last, so so it will go through to the base. So then I draw another circle at the center of the base. Then I again pocket it to up to last. So it will have the curve at the center of the base. So next, so this is the it's supposed to be the fifth step of the pocket. No, the base. So the upper one is basically the fifth step, and another the bottom one is the step 6. So the fifth step, I will draw. If you can see, I draw the circle, two circle and two ellipse on the upper base of the on the upper surface of the base. So then I pocket it to up to last. So I get the hole. So then again I draw another two circle at the bottom of the base. So then I pocket it to 12 millimeter. Then I get 12 millimeter hole on the bottom of the base. The next, so this is the complete design of the base. So this there are two holes, no, two holes of circle and two holes of ellipse. Then I groove on the middle of the middle of the base. Then I fillet edge fillet at the edge there. You can see that fillet. So next, this is a machining of base. So the left picture shown the manufacturing program and the part operation of the base. So 3-axis machine is chosen as the machine, and design part and stock, and another one is safety plane is selected. So the first machining that I applied on the base is roughing. So we can see on the right picture that I choose concentric as my type of machining. So next, so the second step, I apply sweeping on the base. So I choose the part, I choose the all I choose the part body of the base as my part. Then we can see that I choose the path that shown in the right picture. So the next picture is the third step of machining, which is drilling. So I apply drilling on the groove that I sketched on the design previously. So then I apply 60 millimeter. So due to its height from the top surface of the base. So next. So the last step is another roughing, but on the lower part of the base. So in this step, I changed the tool axis to -1 on the Z axis. So I got the roughing on the lower part. So I choose the part board on the base as the part, and then I apply it, and then I stimulate it. So the right picture is final look of the base after 4 step of machining. So next. So this is the video simulation of base. So this is the first step of the machining. Then this still this first step. It actually took a lot of time to machine for the first step of the machine, which is roughing. So this is still the first part. Still the first part on the hole, and then it will go to the ellipse. So now it's moving to the sweeping for the second step of the machining. So this is the last step of the machining, which is roughing on the lower part. So basically that is the video simulation of the base. Next. That's all. Thank you. Thank you. That's all from my part. So I will pass the next part to Shikin. So thank you.
So thank you, Farhana. So for my part, I'm doing the bearing breast. So for this one, this is the drawing basically for the drawing breast. So it has the front view, left view, top view, and also the isometric view. Next. Okay, as for the design, the first step is I'm sketching the body on the XY plane. The next step is I'm doing the shaft definition, and I change the first angle into 180 degree. Next. Okay, so the third step is I'm sketching again onto the body of the bearing breast. So I'm doing the small circle with the radius of 3 millimeter. The next step is I'm doing the pad definitions before. Pad definitions with 33 millimeter. So the fifth step is I'm doing the sketch again onto the top part of the bearing breast with the radius of 25. Next, I'm doing the pocket definitions, which I'm using the up to last pocket. Next. Okay, so this is the final looks of the bearing breast. So basically, I'm doing this 2 bearing breasts. So this is the upper part and also the lower part. Next. So for the machining, I'm using the milling machines on machining the bearing breast. So basically, the left side is the manufacturing program and also the part operation that will be used on the machining of on the bearing breast. So the first step, I'm using the swept roughing, which is on the upper part with the tool axis is going upward. Next. So the second step, by using the swept roughing, I'm doing the upper part also, but by changing the maximum distance between passes into 1 millimeter. The third step, I'm using the sweeping. This is for the lower part of the bearing breast. Next. So the first step, I'm using the roughing again, but on the lower part with the tool axis going downward. And the fifth step is going the sweeping on the upper part of the bearing breast. Next. So this is the final looks at the end of the simulations of the bearing breast basically. So next. So for the video simulation, it kind of long, about 5 minutes. So Najia will going to skip. Okay. So I can see it. So basically, this is the swapping, the roughing swapping of the bearing brush. Okay. So the machining is going on the lower part of the bearing brush for this one. Okay, so next. Mm? Mm,
I think that's okay. We are
never,
unable to
yeah.
play. Yeah. Okay.
Never mind. We are going to the next
So,
one.
View, left view, top view, and isometric view. Next. So this is the how I design the 3D board. First, I create the profile based on the left picture, and then I do a shaft. I do a shaft about the axis, and then it form the product. Next. So after that, I do a helix curve by using generative. After selecting generative shape design, so I set pitch is 3 mm and height is the 45 mm, and the starting point is the edge of the surface for the boat, and in the way is inward. Okay, next. Okay, the fourth step is I create a plane based on the helix, which is on the end of and at the starting point of the helix, and it is stated that I choose normal to curve to make the helix. Next. Okay, after that I choose a slot, which is it is based on the profiles, which is cache 20, which is the helix. And then the center curve is helix 1, and after that I choose the reference surface which is the surface of the shaft. Okay, that's all. Next, for the shaft definition is I set it is 360 degree. Next. Okay, that's for the stock. That's for the stock. Okay, so after that, this is the final looks of the 3D bolt with the stock. Okay, next. Okay, this is the 3D bolt design without the stock. Next. Okay, this is the how to create the manufacturing process of the bolt. First, we choose the part. We choose the last program, which is after machining, and I choose and I choose the and I choose the screw. The body is part body, and the stock, which is body, which is stock that I create. And after that, I choose rough turning, which is for the first step. It is the part offset I adjust 0.5 mm to make space for the finishing process after this. Next. So the second step is thread turning. It is for the helix that I create in the design. So that's the second step. The third step is finishing, profile finishing. So I set the part offset is 0 mm because it is the last step. Next. Okay, this is the final product of the 3D bolt after the video simulation. After the video simulation. After all the three product is finished. So this is the video simulation. Okay. At first it is okay, but and in the center of the process it is stuck. I don't know why, but it still can proceed. Yes. Okay, that's it. The finishing. Okay, this is the last picture of the product. Next. Okay, this is the drawing for the plumber block, which is we have front view, left view, top view, and isometric view. Next. So after that, we proceed to the second step for our project, which is to generate CNC code. The first step is after the process is done, we need to choose. We need to make sure that the post processor and controller emulator was set as MAS and extension in CAT and C format. Next. Okay, after that, we click the right click on the manufacturing program and select generate NC code interactively as stated in the figure. Next. Okay, for the format, we need to choose based on the machine type, which is for the milling, we need to choose Okuma, and for lathe, we need to choose Maza. Next. After that, we choose, we click execute, and it will produce the CNC code. So for the conclusion is the plumber block machining process are using lathe and milling machine to produce the part. For the threaded bolt, it use lathe while bearing, as example, threaded bolt use lathe while bearing press use milling for the machining. So that we generate CNC code for the machining of the part and assemble all the part to produce from plumber block. Next. Okay, this is the isometric view of the plumber block. It look nice for me. Next.
That's all for our.
Next. Habis. Okay, that's all from me. That's all from us. I hope all of you get a lot of information from our project. Thank you.
Thank you.
Thank you.